Hello, so we are back, and this time we have a different kind of job. So what do we have here? We have a wireless router, probably it's an expensive one. Uh, anyway, the customer sent it here for repair. So I will say let's find a plug and see what it's doing. I can see it's 19 volts. Let me grab a plug. Okay, so we have 19 volts. Let me lower the current a little bit. Plug in the charger. 300 milliamps because that's the limit. Check the voltage. The voltage gets dropped to 0. So the Wi-Fi router is shorted. And that's bad because I have no spares for this router. I mean, if it's a chip or a power supply. I can see someone open it before. Well, let's see what we can do, what we can fix. How this is getting open? I have to open all screws here. So how is everyone? It's Tuesday. I'm really sorry I haven't posted on the last period of time. But I was, mad busy. You know what I mean? Because Diablo 4 Season 3 came out and I had to play it. I managed to do like level 95, I believe. Yeah, pretty nice. So how this is supposed to be open? I don't understand. So here has two clips. No, these are buttons. Sorry, are buttons. So I open the screws here. This is the weirdest design I ever met. Wait. Okay, finally. So what do we have here? It's a nice board. So the charging port is here. I can't see anything on this side of the board. Obviously the charging port is shorted. We have to take this board out. Finally. Wow, that's a big heatsink. So check here on the charging port, we have the input circuit. We can see a Mosfet, we can see a diode there. So what do you think is faulty? Because it's weird. Remember, the voltage get dropped to 0 volts. I mean, if this diode, it will be shorted, right? Will be after the MOSFET. So either are both shorted, the MOSFET and the diode, or the short is on this side. Let's grab the multimeter. And let's check to ground. Checking to ground, we have 2 ohms. And the MOSFET has 0 ohms. So both are shorted, the MOSFET and the diode. Now the solution is extremely simple like usual, yeah? Let me grab the solder iron. We're gonna apply a simple fix using a proper calibrated wire, yeah? Or fuse. Fuse? You want a fuse? Yeah, we can do a fuse. We can see here the manufacturer didn't fit a fuse. So we can do it. Let's desolder the diode first. We can do something nice with this diode? Yes. No, I can't desolder. Let's come with some 180 degree solder just to lower the temperature of the solder. I don't think it's enough. You know what? Let's come with 140 degrees solder. Okay, now it's better. So now we can play with the solder iron. But okay. So what I was trying to do is to desolder this diode. Perfect. Now let me clean quickly. Actually, you know what? I was wrong. We don't need a wire. So what do we have here? We have a shorted MOSFET. And we remove the diode and we still have short. Lol. Okay. We have 1.7 ohms. Okay, it's bad. So we remove the diode. This MOSFET is on the serial mode with the charging port. You can see the charging port here. So even if we remove the... Wait, the diode is not even shorted. I can't believe. Check here. The diode is not even shorted. So what is shorted is the MOSFET and it's something else. And that something else, it's making me worry. So what I will do, I'll solder back the diode because I was wrong. I thought, you know what, the diode is faulty. But I can see here someone probably did the same mistake as me. They soldered the diode, and after that, they realized, wait, it's not the diode. Okay, that's bad. That's proper bad. And what we can check? Nothing. What we can do? We can comb with the thermal camera and see what is getting hot. So I'll plug back the charger. The charger is plugged, still short. And let's see. So we work here, that's why it's warm. And if something shorted here, right? Let's raise the current. Check that. So if we're raising the current, you can see 1.4 amps, we can see exactly what's the problem. It's which one? Here we have two capacitors. Check that. Yeah, you can see them. But both capacitors are shorted. Okay, that's strange. Let's comb with some alcohol. Some alcohol. Nah, it's only one. You can see it? It's this one. You can see it's this one. Yeah. Okay, let's remove that capacitor quickly. Perfect. So we remove the capacitor. We're gonna replace the capacitor on a different video, not on this one. Let's check for short. Let's see, do we still have short? Multimeter. So checking the same diode and we have no short, you can see. The MOSFET is still short, but that's fine, you know. That's, you know. Our job is to bring this to life. Plug in the charger. 140 milliamps. It's looking good. It's looking fine. We have a light here. Check that. Let's wait and check the Wi-Fi signal. Yeah, it's working. Check that. ASUS. You can see full signal. Yeah, that's the one. Okay, so what about the input MOSFET? Let's have a look what is there. 40P06. Yeah, I found it. Check here. Yeah, that's the one. Let's see the data sheet. So this is a trench FET power MOSFET. Channel P, you can see it is channel P. So we have to find a channel P MOSFET. Okay, that will be a little bit hard to find a channel P MOSFET. VGS 10 volts. So I believe, you know, with the between the 4 and 10 volts, the internal resistance is about the same. So let me try to find a P-channel MOSFET. Just give me 1 second. Okay, I found it. This is an old HP board. That's the one, yeah. P1003. And on the screen, yeah, I found it. It's about same specification, different type of Mosfet, but it will do the job just great. About same gate to source voltage. Yeah, should be fine, you know, should be fine. So let me take out this MOSFET. You know, I can leave it like that and it's working. But I will see again people in the chat moaning, why didn't they replace the MOSFET? So let's replace it, you know, just to make everyone happy. That's all, just to make everyone happy. That's the only reason. That's the only reason. What this MOSFET is doing here, probably, you know, you have the ability to shut it down completely, remotely or whatever, and this MOSFET can do it. And that's the only reason why you have a MOSFET here. Otherwise, I can't see what this MOSFET is doing here. So where is the pin number 1? Yeah, there. Pin number 1 is there. Okay, let's solder this one. Perfect, right? Or nearly perfect. You said nearly? Yeah, it can be nearly. That's perfect. Those pins are all free together. And actually solder them together with solder, the MOSFET, it will have a better cooling. So I really recommend, if you love your electronics, to do this kind of trick on like laptops, on anything, yeah, just adding more solder, the MOSFET, it will have a better cooling. Now let's test it again. Plugging, and this work. We did something wrong. Probably need more current. Yeah, let's see now. 1.7 amps. Why? Why I'm trying to make the other people happy? I don't understand. It was working fine before I replaced the MOSFET. That's crazy. Yeah, probably something is too hot. Most likely this diode, and now the diode got shorted, right? Okay, let me cool down the board. Hopefully it's not a chip or something else. Yeah, we do have a chip on the other side of the board. Nah, it's not working. It's shorted. I can't believe. Okay. But it's shorted badly. I mean, wow, the MOSFET is mad hot. And it's not the first time it's happening. It's not the first time. I tried before on the same way, and I failed. So after the MOSFET, we have 1 volt. Let's see what is getting hot. The MOSFET, okay, I got that. Yeah, the MOSFET, it is getting hot. What is here? Okay, it's the MOSFET. And what else? Wait, so if I short the MOSFET, right? It's working? No, it's 1 volt. Yeah, something died. You're right. I have 1 volt on the other side with 220 milliamps. So what died? Let's see. Why this switch is not working? I can't believe I broke the router. It was fine. It was working fine, no problems. Wait. Let's raise the current. It's the second capacitor. I can't believe. This is crazy, you know what I mean? And if I will remove the both capacitor from the beginning, the people will say, sorry, why you remove a good capacitor? It's the second capacitor which died. Okay, let's remove that capacitor. Okay, so we remove the capacitor. And believe it or not, I'm not happy to leave this board without any capacitor. Because that's a switching chip. And I mean, we can remove a capacitor. Even without 2 capacitors, it will work fine. But it is possible the efficiency of that power supply goes down. And when the efficiency is going down, the chip is getting hotter. You know what I mean? So I will say if we remove 2 capacitors, let's be sure we are soldering back another one. Let me dip the capacitor on rosin. Perfect. Now we do have flux. Perfect, right? Perfect, yeah. But I mean, what are the odds actually, you know, a capacitor to die on the same time I'm replacing a MOSFET? I mean, it has no connection at all. Nothing, no connection. It just happened. It's a coincidence. Okay, so we cool the board down. Let's plug the charger now. It's working, I can't believe. It's working. No, we don't have picture, but it's working. Let's check the voltage again. So before the MOSFET is 19.4, and after MOSFET is 19.4, so the MOSFET is working fine. Switching off. Lol, I can't believe. So this switch, yeah? This switch. No, this MOSFET, all what is doing, it's the gate is switched on and off by this gate, by this button. Probably the gate is going somewhere into the circuit also. But that's how the power switch is working. It's switching the gate. And to prove that, let's check the input voltage. Check there, we have 19 volts, you can see. On the output of the MOSFET, we have 1.4, basically nothing. And the gate of this MOSFET it's 18 volts, you can see. So if I switch this one, and the gate is going down to 13 volts. Yeah, that's making sense. And it's working fine. Let's check the Wi-Fi one more time, and the job is done. Okay, so if you have this laptop, if you have this router and you want to fix it, I'm gonna tell you what voltage you have. So on this power supply, you have 5 volts. So you can swap it with like a general switching power supply if it's faulty. And here is 3.3. So you have 5 volts and 3.3. Just to know. And this one, probably this one must be around 1 volt. But let's be sure. We have, 0.9. Check on the screen. Yeah, this one. Now let's test with the phone again to be sure it's working. Yeah, it is working. You can see the ASUS. Yeah. Okay, all good. So I'm gonna stop now. Hopefully you enjoy the video. Now these things can happen, yes, and it did happen on the past. I mean, you fix something here, and when you test it, you realize something else, so somewhere else died something, and it just has no logical. It's making no sense at all. But yeah, you see, coincidence happened. So I'm gonna stop here. I will say thank you for watching. Like, subscribe if you like the video, and see you on the next one. Bye.